Hi, welcome to Unit 1, Scientific Skills and Matter, Day 2. There are 3 objectives for this video. Define matter, atoms, and molecule, describe the phases of matter, and define the classifications of matter. We're going to start by talking about matter and the 3 phases of matter. So why do we talk about matter in a chemistry class? That is because chemistry is the study of matter. And matter is anything that has mass and occupies space. Chemists study matter by observing chemical and physical changes, measuring the chemical and physical properties, and collecting and analyzing data and drawing conclusions about matter based on those chemical and physical properties. Now, a good way to understand something is by presenting not only an example of the thing that you're trying to understand, but also a non-example, something that does not classify. So let's do that with matter. A lamp is an example of matter. It has mass and it occupies space. Light, on the other hand, is a non-example, and that is because you cannot weigh light, it does not have mass, and it doesn't occupy space. Air is an example of matter, and oftentimes we don't think of air as an example of matter because we don't really see it, it seems like there's nothing there. But that's not quite true, and one way we know that is if you blow up a balloon, the size of the balloon gets bigger and the balloon expands, and that is because the air inside the balloon is taking up space, it occupies space. So air is an example of matter. And you can also weigh air if you have a very powerful scale. So air also has mass. Wind, on the other hand, which is the movement of air, is not an example of matter because you can't weigh the movement of air and you cannot, and it does not occupy space. So let's try this to see a few. We're looking for examples and non-examples of matter, and let's consider the heat from the campfire and the wood on the campfire. So you're going to pause the video now and you're going to identify whether the heat is an example or non-example, and whether the wood is an example or non-example of matter, and explain. When you press play again, the answer will be revealed. So wood is an example of matter, and that's because you can weigh it and you can measure its volume and occupy space. And it's also made of atoms, which we'll talk about in a moment. The heat is a non-example because you cannot weigh it, you cannot measure its volume, and it's not made of atoms. Now there are 3 phases or states of matter: solid, liquid, and gas. On your handout, you are going to make sure you write down this information, and what you're going to do in these boxes is draw the particle diagrams of the solid, liquid, and gas. So let's take a look at those particle diagrams. Notice for the solids that the particles, these circles here, are really close together, and they're arranged uniformly, meaning they're arranged in neat rows and columns. For the liquid, on the other hand, the liquids, the particles are close together, but they are arranged randomly. And for the gases, the particles are very far apart, and in fact, the particles take up the entire space of the container. So let's talk about why that is. Solid particles are really close together, and they only vibrate in place. So as a result, solids have a fixed shape, meaning they keep whatever shape that they have. They have a fixed volume, meaning that they keep the volume that they're in no matter what volume container that they're in. On the other hand, liquids, the particles are close together, but they actually flow over one another. And as a result, they take the shape of the container that you put them in. However, their volume is fixed. So if you start off with 1 liter of liquid and you put it into a 2-liter container, it will remain a liter of liquid. Gases, finally, the particles are really far apart and they move quickly past each other. As a result, gases take the volume and the shape of the container that they're in. So their volume and shape are not fixed. All right, so when you're drawing your particle diagrams, be sure to use at least 4 circles in each example, solid, liquid, and gas, and make sure that you are drawing them the solid close together and uniformly, the liquids close together but randomly, and the gases far apart, occupying the entire container and also randomly. The next part of this video, we're going to learn about atoms. So we looked at matter, and now we're going to talk about atoms. So what are atoms? Atoms are known as the building blocks of matter. And in fact, atoms make everything up. So what do I mean by building blocks of atom? That means that they're the smallest unit of matter that still retains the properties or characteristics of the matter which they came from. One way of thinking about that is if you take a gold bar and you split it in half and you keep cutting it in half until you can't cut anymore, what will be left would be a gold atom. And it's still considered gold. Even though it's not a gold bar, it's still considered an example of gold. Now, there are 118 different types of atoms, which you can find on the periodic table of elements. There's hydrogen, helium, oxygen, sodium, chlorine, copper, gold, to name a few. Now, these different types of atoms can combine or connect to form what are known as molecules. And molecules are substances that have two or more atoms bound together. An example of that would be water. So one way of thinking about matter is and its relationship to atoms, is thinking about how we can break it down to get it into an atom. So let's start off with a glass of water. That will be a bulk sample of water. If you zoom into that water, you would see a bunch of water molecules, like billions and trillions of water molecules. And if you just take out one of those water molecules, one H2O, you could break that apart into two hydrogen atoms and one oxygen atom if you break the bonds connecting the atoms together. And I just want to point out real quickly that this is H2O is known as its chemical formula of water, and it tells you how many hydrogen atoms you have and how many oxygen atoms you have. That small subscript 2, that small number 2, next to the hydrogen tells you have two hydrogen atoms. And the fact that there's no number written next to the oxygen means that there's an invisible 1 there. You have one oxygen atom. So just a quick side note. All right, the next thing we're going to do is we're going to go into classifying matter. So atoms can combine to make different types of matter. And the two main types of matter are pure substances and mixtures. Pure substances are made up of only one element or compound, and it has the same composition throughout. An example of that would be water. Water is a pure substance. It only contains water molecules. A mixture, on the other hand, is made up of two or more pure substances that are not connected by bonds, and they can be separated by physical means, and we'll look at some examples of that. An example of a mixture would be if you mix water and salt together, so that it has two pure substances, water and salt. So first, let's take a look at pure substances. There are two types of pure substances, elements and compounds. An element is a pure substance made up of only one type of atom. Compounds, on the other hand, are pure substance made up of two or more types of atoms. So examples of that of an element would be something like helium, which is used to blow up balloons, only has helium atoms. And oxygen, O2, which is the oxygen that we breathe, is an element. Now you may be thinking, wait, there are two atoms there for oxygen. Yes, there are two atoms, but they're two of the same types of atoms. So that's what makes it an element. As long as it's the same type of atom, no matter how many you have, it's an element. Example of compound, on the other hand, would be water, H2O, and sodium chloride, NaCl. Sodium chloride is also known as table salt, the salt that you put on your French fries. So these are compounds because they're made up of different types of atoms. Water, for example, is made up of hydrogen and oxygen atoms, and sodium chloride is made up of sodium and chlorine atoms. All right, so we have two examples here, CO2 or carbon dioxide and chlorine. Which substance is an element and which one is a compound? And be sure to explain. Pause the video now. When you press play again, the answer will be revealed. All right, CO2 is a compound, and that's because it's made up of two different types of atoms, carbon and oxygen. And chlorine is an element because it's made up of one type of atom, chlorine. All right, so we talked about pure substances. Now let's go into mixtures. So pure substances can be combined to make mixtures. Let's take, for example, water and salt. These are two pure substances. And if you mix them together, you can make a mixture of salt water. Now, there are two types of mixtures. Salt water and tea would be an example of what's known as a homogeneous mixture, and that's because it looks the same or uniform to the naked eye, or if you looked at it under a microscope. So homo meaning the same. Heterogeneous mixture, on the other hand, does not look the same under a microscope or to your eye. So an example of that would be this sand in water. Notice how the sand is settled on the bottom, the water's on top, and you can see the two different parts. They're still mixed together, they're still combined. However, you can see the different parts. So hetero means different. Now you can separate mixtures using physical means. For example, the sand and water we can separate by filtration. We don't need to break any bonds. All we need to do is just pass it through a filter paper. So for a mixture, you can separate them by physical means. Something like salt water, a homogeneous mixture like salt water or the tea, you can separate by using a process called distillation, where you heat up the mixture and the liquid water will start to evaporate, and then it will come down this tube and condense, and then drop on this other container as liquid water. So look at some more examples of homo versus heterogeneous mixtures. Gatorade or a saline solution, saline which is oftentimes used in hospitals to sort of clean out wounds, would be homogeneous solutions. They look the same to your naked eye or under a microscope. Heterogeneous solution would be something like Italian dressing, where you can see the oil and the vinegar separated, and you can also see chunks of herbs, etc. So you can see that with your eye. But two other examples you may not know are heterogeneous are blood and milk. And you may be wondering, why is that? Well, the key thing is that a heterogeneous must look the same under with our naked eye or under a microscope as well. And if you look at milk or blood under a microscope, you can actually see the different parts. So this is milk under a microscope. You can see the fatty parts separated from the more watery parts. More examples of homogeneous mixtures that are not liquids would be something like a metal alloy. Copper and zinc make up brass, and so if you look at that, it looks like all like one thing, but it's actually a mixture of two different metals. Air is a mixture of different gases, and oceans and lakes are examples of homogeneous mixtures because they have oxygen dissolved in them. All right, try this CFU. Which substance is homogeneous mixture? Select all that apply. Pause the video now. When you press play again, the answer will be revealed. All right, the answer would be steel and black coffee. Both of those are homogeneous mixtures. They look the same to our naked eye or under a microscope. All right, homogeneous solutions, also known as mixtures, are also known as solutions. And a solution has two parts. It has a solute, which is the stuff that gets dissolved, and a solvent, the stuff that does the dissolving. A good way of thinking about that is thinking about making something like Kool-Aid. So the Kool-Aid powder would be your solute. It's the thing that's going to get dissolved. The solvent would be the water. That's the stuff that's going to do the dissolving. And the solution is the resulting mixture, homogeneous mixture of the Kool-Aid and water. So your Kool-Aid drink would be your solution. All right, quick summary. So matter is anything that has mass, occupies space, and it's made up of atoms. Matter is classified by what it's made of, and there are two main types of classifications: pure substances, elements and compounds, and mixtures, homogeneous and heterogeneous. A quick way of keeping track of it is by using a flowchart. So if we take something like matter and we ask ourselves, is it made up of one type of element or molecule? If our answer is no, we know we're dealing with a mixture. But if it's yes, we're dealing with a pure substance. For our mixture, we can ask ourselves, is the composition uniform? Does it look the same? If the answer is yes, it's homogeneous mixture or solution, and if it's no, it's heterogeneous. For a pure substance, we can ask ourselves, is it made of one type of atom? If the answer is yes, it's an element, and if it's no, it's a compound. All right, that's it for this video. Have a quality day.